The next question is, the waveform of a periodic signal x of t is shown in the figure. Now, a signal g of t is defined by g of t equal to x of t minus 1 whole by 2. It's a time scaling operation, right? Time shifting and time scaling. So time domain operation. I can write it's a time domain operation. Now, the average power of this new signal g of t is. Okay. So, what we have to take care of in this question is, if a signal is time shifted or time scaled, its power is unchanged. Okay, its energy changes. We have already seen a question in one of the previous video. So now power is constant if it is time scaled or time shifted. Okay, power remains constant. So instead of finding the power of average power of g of t, we need to find the average power of x of t. Okay, so let's find out the average power of x of t. Before that, what is the time period of x of t? Time period of x of t is, it starts from -1 and ends one complete cycle at t equal to 2. Okay, so t equal to -1 to t equal to 2. Therefore, time period is equal to 2 minus -1 equal to 3. Okay, so 3 is the time period of the signal. Why did I find out the time period? Is because of the expression of power, average power. Average power is given by 1 by t, integral over one complete time period. Okay, 0 to 1 complete time period, mod x square of t. This is a real signal, so x square of t dt. Okay, so there is an involvement of time period here, so that's why I have found out time period as 3. Okay, now we can substitute in this equation. So this is 1 by 3 into integral over, the signal extends from -1 to 1 alone. In the duration 1 to 2, it is 0. So you need to integrate only from -1 to +1. So -1 to +1. Instead of one complete time period, so from -1 to +2, we need to integrate only from -1 to +1. Okay. And -1 to 1, x square of t. What is x of t in that interval? You have to formulate an expression for x of t. X of t equal to, what is x of t? If that signal was like this, then x of t will be, we can straight away write it as t. But instead of this, the signal is like this. That is t folded, right? T folded about by y-axis. So I can write x of t equal to -t. Okay. Now x of t is not exactly -t. Because we have to take care of the slope of the signal also. Slope. What is the slope of the signal? Slope is delta y by delta x. Delta y is actually 3 minus -3 is 6. Slope is equal to 6 divided by delta x is actually -1 to +1. So 1 minus -1 is 2. So slope is equal to, is it 6 by 2 equal to 3? No, because this is a descending signal. So slope is -3. Okay, so exactly x of t equal to -3t, right? Okay, now we can integrate 1 by time period is 3, integral from -1 to +1. Instead of x of t, we will give -3t. So x square of t means 9t square. So 9t square dt, that is equal to 9 can be taken outside. So this is 3 into integral t square, that is t cube by 3 within -1 to 1. So this is equal to 1 plus 1 equal to 2. So average power of g of t is, the answer is 2. Okay, now let me spare some more time in this. What happens if we find out the power of g of t as it is? If we find the power of g of t as it is, that means x of t minus 1 by 2, what happens? What happens is, it will be very strenuous. First of all, we have to find out what is x of t minus 1 by 2. For that, we have to first find out x of t minus 1, then find x of t minus half, then find x of t by 2 minus 1 by 2, and you will get a signal which is shifted and scaled, something like this. Okay, so now we have to again recalculate the new time period, integrate it over the time period. The integration limits will be changed, so the entire integral will be a little bit more strenuous. So what happens is your entire time will be lost. Time will be lost. So if you know this relation, you will get the answer within seconds. But if you don't know this, you lose your time very much. Okay, so that's the answer to the question is 2.